discuss about full wave rectifier. Now we are going to discuss about full wave rectifier. So let me draw the circuit diagram for full wave rectifier. I will have my AC power supply. That is given to primary of the transformer, single phase AC power, primary of the transformer. Now the transformer is center tapped transformer. The transformer is a center tap transformer. I will use two diodes in my full wave rectifier. Of a rectifier, we were using only one diode. In full wave rectifier, we will be using two diodes. So here is my load RL, and I will have one more diode here. This symbol states there is no connection. So this is my diode 1 and this is my diode. So I have two diodes in my full wave rectifier. This is the circuit. Now what happens in full wave rectifier? The input is the input waveform is AC. As we know, the input is AC, so on till infinity. So this is 0. So input, this is pi, this is 2 pi, 3 pi, and then we have 4 pi till infinity. Then what is the output current? What will be the output current waveform? So 0 to pi. Then for negative cycle, even the negative cycle is converted into positive cycle in full wave rectifier. So this is the output for my full wave rectifier. So what happens actually? Initially it is positive, negative. Say for this positive cycle of the input, this is positive, this is negative. Positive, negative, right? Positive, negative, positive. Fine. For positive cycle. So my D1 will be forward biased. D1 will be forward biased for positive cycle. How about my D2? This is positive. How about the other end? Here, my D2 will be, say, reverse biased. Okay. Now, for negative off cycle, my D1 will be reverse biased and my D2 will be forward biased. Okay. So for both the off cycles, positive negative off cycle, in my load, the current direction is unidirectional. The current is unidirectional. So that is my output current. Okay. Fine. Now, what is the average current? Average current of the output or output average current, which is equal to IDC, output DC current. So this is my output. Time period is pi. So 1 by time period, area divided by time period. Time period is pi. What is the area? Area is integral 0 to pi im sin theta d theta. So from this, my IDC is equal to Im by pi integral 0 to pi sin theta d theta. So that is equal to Im by pi minus cos theta. If you integrate sin theta, you will get cos theta minus cos theta 0 to pi. So this will give Im by pi minus cos pi minus of cos 0. So this will become plus, minus minus will plus. So that is equal to Im by pi. Cos pi is minus 1. Minus of minus 1 is plus 1. Plus 1. Cos 0 is plus 1. So that is equal to 2 Im by pi. That is my IDC. So IDC, which is equal to I average, is equal to 2 Im by pi. Right? Fine. Now what happens to my IRMS? I have to find what happens to my IRMS. So IRMS is equal to time period pi. So 1 by pi integral 0 to pi root square root of Im square I theta square d theta. So if you take square on both the side, I RMS square is equal to 1 by pi 0 to pi. We can take Im square outside. So Im square sine square theta by d theta. So we know sine square theta can be written as 1 minus cos 2 theta by 2. So substitute that. So IRMS square is equal to Im square by pi integral 0 to pi 1 minus cos 2 theta by 2. 2 can be taken outside. We will get by 2 pi d theta. Now let us integrate. So IRMS square is equal to Im square by 2 pi. Integrate 1, you will get theta minus. Integrate cos 2 theta, you will get sine 2 theta by 2, 0 to pi. So IRMS square is given by IRMS by 2 pi minus sine 2 pi is 0. Then minus 0, 0. Minus of sine 0 is 0. So the result is IRMS square is equal to Im square into pi by 2 pi. So pi will get cancelled. You will get Im square by 2. So take square root on both the sides. You will get IRMS is equal to Im by root 2. That is my IRMS. Or full way rectifier. That is the IRMS for full way rectifier. Fine. Now let us calculate what is the ripple factor. Ripple factor for full wave rectifier. We know ripple factor is given by root of, we can check the half wave rectifier. Ripple factor is given by root of ERMS by IDC, the whole square minus 1. So that is equal to Im by root 2 the whole square divided by IDC. My IDC is given by 2 Im by pi square minus 1. So what will happen? Im will get cancelled. We will have pi square by 8. So it is equal to pi square by 8 minus 1. So that will be my ripple factor. That is root of pi square by 8 minus 1. So what is that equal to? 0.48. Pi is 3.14. So substitute pi is equal to 3.14. You will get ripple factor is 0.48 to 0.48. That is my ripple factor for full wave rectifier output. Okay. Now we have to find what is the rectifier efficiency. What is going to be the full wave rectifier efficiency? We know rectifier efficiency is given by EDC by PAC, as we saw in half wave rectifier. That is equal to IDC square RL divided by IAC, that is IRMS square RL. The drop across or the loss across diode is neglected because RL is greater than your RD, where RD is diode resistance. Now what is my efficiency is equal to? My efficiency is equal to RL will get cancelled. IDC square by IRMS square, that can be written as IDC by IRMS the whole square. So efficiency is equal to IDC. What is my IDC equal to? IDC equal to 2 Im by pi divided by IRMS. My IRMS is equal to Im by root 2. So this becomes 2 root 2 by pi the whole square. Efficiency is equal to 8 by pi square. So rectifier efficiency is 8 by pi square. So 8 by pi square is given by 0.812. In percentage, it can be written as 81.2 is the efficiency of the rectifier. Right. So I will repeat what we have done in full wave rectifier. This is the circuit diagram of full wave rectifier. Input of my rectifier, output current of my rectifier. we don't have any negative cycle, we have only positive cycles. Then we calculated what is I average of IDC, I average, they are one and the same. IDC is equal to I average is equal to Im by pi. Then we calculated what is IRMS. IRMS is Im by root 2. Ripple factor, we know the formula. After substituting the formula, we get ripple factor is equal to 0.48. Then we have our rectifier efficiency, which is equal to 81.2. Found out our rectifier efficiency to be 81.2. Okay. Fine. Now I will repeat the operation once again of my, I will repeat the operation of my full wave rectifier once again. So during positive off cycle of my input, during positive off cycle of my input, this will be my, say this is A, this is B terminal. A terminal will be positive. Sorry, B terminal will not be positive, B terminal will be negative. Okay. A terminal will be positive and B terminal will be negative during positive off cycle. Okay. During, this is what happens during positive off cycle. So in A is positive, D1 is forward biased. How about my D2? D2 is reverse biased. So the current will flow in this direction. Current will flow in this direction. Okay. For positive cycle, this is my current direction. Right. Now for during negative of cycle, during negative of cycle of my input, what will happen? This will become positive. My B will become positive and my A will become negative. So my D2 is forward biased and my D1 is reverse bias. So what will happen during negative cycle? This is my current direction. This is forward bias, so this will be my current direction. Right, but during both positive cycle and negative cycle, the current direction in my load or the output current direction remains the same. Say this is my first point and this is my second point. For both D1 on and D2 on, that is during positive and negative of cycles respectively, the current direction in the output or the current direction of the load remains the same from point 1 to point 2. So we can say in the output, the current direction is unidirectional. It is not bidirectional. Here in the input, the current direction is bidirectional. But output is unidirectional. You have only positive cycles. You don't have any negative cycle. Hope you understand. I will repeat. So during positive cycle of the input, D1 is on, D2 is off. So current direction in RL is from 1 to 2. During negative off cycle, D1 is off, D2 is on. On refers to forward bias, off refers to reverse bias. So the current direction once again remains from 1 to 2. So the output current direction is unidirectional. So this is about my forward bias and reverse bias which is occurring in my full wave rectifier, and this is the operation of my full wave rectifier.